Go on. Thank you. Hello, SolidWorks. My heart is beating so hard that if I had SolidWorks simulation on me today, I would run a frequency analysis of my coronaries. It's a great pleasure for me to be here today. It's an honor. Before anything, I would like to say thank you to Mr. Gianpaolo Bassi and the entire SolidWorks management team for their exceptional leadership in the industry. I want to thank you for leading the way into the future for us and for delivering an entire product design and development ecosystem to all of us around the globe. A special thank you goes to Matthew Forcad. Thank you for being my point of reference for all these years. And of course, I cannot forget all of you. You're the driving force behind the most complete, easy to use, yet so powerful CAD system in the world. You, the SolidWorks developers. Thank you for the work that you do, and thank you for the passion and dedication that you put in the work you do. Thank you for listening and creating a better software experience with every new release of SolidWorks. It is because of your passion and dedication that today I can stand here with pride and show you some of the things that in my short professional life I've been blessed to work on. Sorry, this is not working. Yes, it is working now. I would first like to share my personal love story with SolidWorks. Then I will briefly introduce the company I work for, Standard Model Products, and finally dive into some interesting projects that SolidWorks helped me execute. My name is Gianluca Mattaroccia. I was born and raised in Italy. In 2006, I earned a master's degree in mechanical engineering from the University of Cassino, a major in machine design. I'm currently a senior tool design engineer and the SolidWorks administrator for Standard Model Products. I've been a SolidWorks user since 2003. I have been a SolidWorks certified professional user since 2009. I've designed more than 400 machines with this software and spent over 25,000 hours on it. This is me, 1995, a little younger, lots of hair. And yes, I was wearing a pajama. It used to take me the whole night to complete a drawing just to see everything vanish in a matter of minutes, when a single drop of ink would just, on the paper, would just make you jump out of the window. No copy-paste option, just nothing. Just start all over again until morning. And by the way, I am very glad to be among those who have been experiencing the change from manual drawings on paper to 2D CAD, to 3D parametric modeling, to model-based definition, to possibly virtual reality. I've almost seen it all. 1998, my father buys for me a PC running Windows 1995 and AutoCAD Release 13 running an MS-DOS. That was the light after the tunnel. Faster drawings and plenty of opportunity to fix things. 2001, with AutoCAD 2000, I started creating some 3D models. You will remember, lots of typing in the command line. But that was another great milestone. 2003, Massimo Cavacece, professor of mechanics of vibration at the University of Cassino, introduces me for the first time to SolidWorks. I remember sitting in class when Massimo said, well, SolidWorks is what I'm expecting you to use from now on. We all looked at each other. We said, after Pro Inventor, Solid Age, are we really going to invest any more time in learning another software that will probably be outdated in 6 months from now? Well, he was a sort of a visionary back then, and he must be proud of me today, or at least I hope so. Thank you to Massimo and all the teachers in the conference here today that helped students make important decisions about CAD systems early in their career. I'm sure others are doing the same, and that's probably one of the reasons why SolidWorks is so powerful and so successful today. Since then, SolidWorks has been my only CAD software. In 2006, 3 days after my graduation day, I buy a ticket to New York, and soon after I go for the very first formal training on advanced assembly and Cosmos motion. I started to get more serious about SolidWorks in 2008 when I passed the certified SolidWorks Associate examination. In 2009, I became a certified professional user. And in 2012, I added the Weldman certification to my portfolio. This, as we'll see later, has allowed me to model complex machines with great flexibility. In 2014, I was honored by SolidWorks by seeing one of my designs published on the SolidWorks splash screen. Thank you, Matthew. I'll never forget. In 2016, I had the privilege to spend a day with the SolidWorks management team in Waltham. I was like a kid at Disneyland, my wife keeps saying. In 2016, I had the sheet metal certification to my portfolio. And this is a picture of me in September designing machine number 442 with SolidWorks. A little story about a great company. Standard Model Products is a leading independent manufacturer, distributor, and marketer of replacement parts for motor vehicles in the automotive aftermarket industry. In 1913, Henry Ford develops and deploys the very first moving assembly line for the automobile industry. A new era was born, and in the streets of New York City, two gentlemen in 1919 established a Standard Model Products with its location on 10th Street. In 1939, Standard Model Products moves to its current location, 3718 Northern Boulevard in Long Island City, New York. 1997, the company is listed on the New York Stock Exchange under the symbol S&P. And in 1992, we appear as Fortune 500 list of America's largest corporations as a leader in the motor vehicles and parts category. S&P today's numbers, over 3 million square feet of manufacturing plants, offices and distribution centers, $949 million in sales, 3,500 employees worldwide. S&P recognizes the value and the potentials of SolidWorks in 1997 when we purchased the very first licenses. Today we run over 50 seats of SolidWorks, including standard, professional, premium, inspection, electrical, and we're adding PDM and composer as well. We at S&P, we design the components from the ground up. Here in the slide, you can see the assembly sequence for a crankshaft position sensor. And we design as well all the manufacturing tooling and testing stations to be deployed in our production facilities. This is the core of the presentation, where I will be sharing with you some of the projects I worked on with SolidWorks. In the last 10 years, I had the privilege to work for different companies within different industries. The most important experiences were in the food packaging, mining, industrial machinery, material handling, and automotive. Starting from the food packaging, a cheese filler, sealer, and capper all in one. There are great emotions attached to this machine. This is the very first project that I believe made me a machine design engineer. Prior to this project, I'd only been involved with small sub-assemblies and parts and revisions, never an entire project. This particular machine has 2,500 parts. The machine is now 6 years old and has sealed over 3 million containers and counting. That's the capping station there. This is a yogurt filler. It's capable of processing 480 cups per minute. It is entirely driven by one electric motor. The rest is pure mechanics, cams, and linkages. That's a simulation that was run with SolidWorks simulation, analysis, motion simulation. This is another great industry I was able to thrive in with SolidWorks, the mining industry. This slide covers the design of a 4-bar linkage and a bucket. The analysis of weldment size and radius is a crucial part of the design here. Fatigue resulting cracks are the #1 cause of failure of these structures. Bucket penetration into material is achieved by bucket curling and crowd forces. For the example shown in this video, the magnitude of these two forces are respectively 21 tons and 26 tons. Loading conditions constantly changing the intensity and direction make the design of these structures really, really challenging. This is a marble bucket. It is designed to detach and move large blocks from quarry walls. Each of those blocks can range from 2 to 10 tons. Simulation is definitely exciting and helps to predict costly failures. This is a bucket that was designed for a quarry located in southern Italy for a excavator Komatsu PC600. The welding of this structure is a 100% manual process, and it takes about 40 working days to complete. The weight of the bucket is about 11,000 pounds, and at full capacity, you can dig 4 cubic yards of material at a time. Industrial machineries. This is a case depalletizer designed and manufactured for public supermarkets in Atlanta, Georgia. Customer deliver milk crates in stacks 3 by 3, 7 high to its supermarkets. Once the empty crates are returned to the filling facility, they have to be washed. This is the very first station of the process, where a forklift places a pallet with empty cases on the infeed of the machine, where they end up single filed and separated from the pallet. The wooden pallets get stacked one on top of each other by a scissor lifter at the end of the drag chain conveyor. That's how they get separated and single filed. And next, the crates will travel to the next station, the top out. This machine receives cases stacked at heights of up to 7 height, then lifts, unstacked, and inverts the cases, delivering them to an overhead case conveyor that passes through a case washer where a high pressure temperature steam jet cleans deeply the cases before receiving fresh bottled milk. This sets a record in the industry with 80 cases processed per minute. This slide takes us to another great industry, material handling. And this is the largest in terms of size project and structure I ever designed. It was designed and fabricated for one of the biggest cranberry processing plants in North America. And while I cannot reveal the name of the customer, I can only tell you that it's very close to ours, and here is Massachusetts. It's a full modular structure, lengths ranging from 40 to 150 feet, speed up to 150 feet per minute, carrying 180,000 pounds of products just in 3 months. That's how long is the harvesting season. This is a pallet transfer module of a large end-of-line conveyor system designed and manufactured for the second largest dairy plant in the USA. Following, it's just a panoramic overview of the process, along with the first animations put together during the commissioning of the project. Animation helps verify cycle times and avoid bottlenecks of the packaging line. And this is another great example on an animation-driven design. A system was designed for a major bottling company in New York to help them single-file and dual-file bottles for their production line. The star wheels are not powered by any external source. The back pressure of the water bottles start the motion of the wheels, and as speed varies, the system is fully autonomous. No adjustments are needed at any point in time. Material handling. This is for the ice cream lovers. Following, it's just a diversified range of conveyors that were designed for Unilever on their Good Humor Breyer and Klondike bar production line. Sheet metal is an extremely powerful tool and environment in SolidWorks, and it poses no limits to the things we can achieve. Full parametric models driven by design tables allowed us to redesign an entire conveyor system in just a few hours of work. This is the smallest machine that I have ever designed. It is almost the size of my hand, as you can see in the picture. It is a desktop machine that our manufacturing engineers use on their desk to bend the soldering terminals of crankshaft position sensors during the validation process. Automotive. Following are a series of testing and validation equipment for ETBs, electronic throttle bodies. A throttle body is a butterfly valve located between the air intake and the intake manifold. It regulates how much air flows into the engine based on driver input through the gas pedal. As more air flows into the engine, it injects more fuel, thus allowing for more power. Each part is calibrated and is validated after. This tester measures the amount of air flowing through the throttle body at different angles of the butterfly plate and the response time. That is the time needed for the butterfly valve to go from full throttle position to engine idle position. This is a calibration station for ETBs. As just to link back to the previous discussion, lots of 3D printed parts of fixtures are making way into our designs, allowing us to achieve higher flexibilities and a substantial reduction in cost. Projects of this complexity, of course, involve mechanical, pneumatics, electrical, and control integration. And I guess this brings to the end of my presentation. I hope you enjoyed my testimonial today. And I want to thank you, SolidWorks, again, for enabling engineers around the world to build better products and faster. Thank you, Gianpaolo. Thank you, SolidWorks.